So how do you plug in regular electrical appliances on your boat that only uses batteries? I'll tell you in a sec. Hi, welcome to the Boat Galley Podcast. I'm Carolyn Sherlock, here with tips, reviews, and how-tos for your cruising adventure. This episode of the Boat Galley Podcast is sponsored by Infinity, the most trusted name in woven vinyl flooring in the marine industry. Since 2008, Infinity has offered boat owners premier flooring options proven to withstand even the most demanding environments. Each of their products is equipped with UV-stable fade resistance and antimicrobial technology, giving them both durability and style that can't be matched. Thinking about kicking carpet to the curb? Make the switch to Infinity and see the difference true luxury makes. Use the coupon code PODCAST for 50% off samples. Slow down, slow down. Okay, two things that I want to say right at the beginning of this podcast. First, I am not a marine electrician, and this is not intended to provide all the answers you might need on the topic of inverters. I'm trying to make it just an introduction. And yes, at times, I'll deliberately keep the explanation simple and not discuss all the possible variations. I'm trying to keep it non-techy. Okay, now, here I'm discussing US, Canadian, Mexican appliances and power needs, which are 110 and 120 volt. European uses 220 or 240, also a number of other countries. If you're listening in those areas, just whenever I say 110 or 120, just kind of substitute in 220 or 240. It'll be the same. Okay, so what is an inverter? Okay, most boats have 12-volt DC power on board from batteries. Things that plug into a cigarette lighter run on 12 volts. Things that have a normal household plug run on 110 or 120 volts AC. An inverter takes the 12-volt DC power coming from the batteries and converts it into 110 or 120 volt AC power that you can plug regular plugs into. So what about portable versus whole boat inverters? Portable inverters are very simple. They plug into a cigarette lighter and then have one or more regular outlets. They come in several different styles. Some have cords that go to the cigarette lighter, some have more than one outlet. Some may also have a USB outlet for charging electronics. Portable inverters are convenient as there's basically no installation. They're easy to put wherever you need them and they're relatively cheap. The downside is that you can't use them for anything that needs a lot of power. Microwaves, blenders, and vacuum cleaners are just some of the things that usually won't work on a portable inverter. For larger electrical loads, you need a permanently installed inverter. They're usually installed by a marine electrician. Because of currents involved with both fire and electrocution a possibility if they're not done right, it's not something to do yourself if you're not trained. Every installation is different, it seems, but basically this type of inverter is larger and installed in a locker in an out-of-the-way location. It's permanently wired to the boat's batteries. Often, it can be a combination inverter charger that also handles charging the boat's batteries from shore power. Most times, there's a switch to turn the inverter on when needed. Depending on how your boat is wired, you may have to plug things in directly to the inverter. That's the case on our current boat, Barefoot Gal. And other boats, such as our previous boat, K-Tall, have the inverter wired to regular household-type outlets in convenient locations throughout the boat that you can plug things into. If that's the case, you'll usually have to turn both the inverter on and the main power on the AC panel. Let's talk about the inverter size. Inverters are sized in watts. Luckily, most appliances are labeled as to how much power they draw in watts also. For example, a microwave might be 1200 watts. The inverter must have a larger watt rating than the item you're using, including the startup load, and we'll get to that in a second. Now, some appliances only state their electrical draw in amps, but if you know the amps, you can calculate the watts. For something running on 110 or 120, take the amps, multiply it by 120, and you'll get the watts. So a regular household appliance, let's say maybe a mini blender, that draws 5 amps at 120 watts AC, that draws 5 amps at 120 volts DC, is the same as 600 watts. In general, portable inverters range in size from about 75 watts to 400. Most cigarette lighters can handle the 75, 150, and 200 watt inverters and the associated loads. However, a 400 watt load can be too much for many and will blow the internal fuse or trip the breaker. If you're thinking of buying a 400 watt portable inverter, make sure that your cigarette outlets can handle it. The receptacle itself, the fuse, the wiring, and the breaker on your electrical panel all have to be capable of handling the loads, and many aren't. A 400 watt load is going to pull about 35 amps DC. It is rare to have something on your electrical panel that will allow 40 watts DC. Because of this, once you get over about 400 watts, almost all inverters are designed to be hardwired into the boat's electrical system. Okay, so let's talk about the startup load. I'm going to confuse the issue a little bit more on how much something draws. In that last step, I talked about determining the load of the appliance you intend to use with the inverter. But its regular running draw isn't the only thing you need to know. Most electrical motors use more power for just a few seconds when they're first turned on. It can also be a bit of an issue for some electronics, although it's not usually near as big of a problem. Figuring out the initial surge draw can be tough. Manufacturers almost never state it, and I've never seen a rule of thumb. There are 2 ways to deal with it. Don't use an inverter that's just barely adequate for the running load. Use at least the next size larger. And second, better inverters usually can handle a brief surge. Look in the specs. For example, a 400 watt inverter may say something like peak surge 1000 watts. Now what do you do if your inverter doesn't work? Okay, there are lots of possible reasons. Let's take a quick look at the basic things to check. If it's a portable inverter, make sure that the breaker is on for the cigarette lighter. Make sure that the switch on the inverter is on if there is one. Make sure that the fuse in the inverter isn't blown. There's usually a fuse in the tip of the cigarette lighter plug. If it's blown, you had too large a load for the inverter or the socket. Sometimes there's a reset button on the inverter too. Did it overheat? If it feels hot to the touch, you may just need to let it cool down. Try to find a cooler place for it. There may be an inline fuse between the socket and the breaker. If so, find out if it's blown. You may just be trying to use too small an inverter to power the item. And last, you did turn on the appliance, didn't you? I've been known to do that and then wonder why nothing worked. If you've got a hardwired inverter, make sure the inverter is on. Make sure that the outlet breaker is on the AC panel. The AC master switch is on. And if the outlet breaker trips, the load was too large for the circuit. Make sure that the ground fault wasn't tripped on any outlet on the circuit. You might have just too small an inverter to power the item. And again, you did turn on the appliance. One more thing. Pure sine wave versus modified sine wave inverters. Oh, I know it's more techie stuff, but this is important. Make the wrong choice and you can fry expensive electronics. AC power that you get ashore from the power company has what is called a true sine wave form. It's complicated to change power from DC current to that smooth wave form. So for years, inverters used what is called a modified sine wave, or a step function. The problem is that certain electrical devices don't like modified sine waves. Electronics and battery chargers, such as for cameras, cell phones, and cordless drills, are notorious for not running properly with modified sine waves inverters. Some displays, like TVs and monitors, will have fuzzy lines on them, and audio equipment may have a buzz, and we totally fried the charger and battery for cordless circular saw by running it on modified sine wave. In the galley, variable speed motors, such as mixers and blenders, generally perform much better with pure sine wave power. The good news is that over the last 8 years or so, pure sine wave inverters have come on the market. They tend to be more expensive, however. Most will state somewhere in the technical specs that they are pure sine wave, although sometimes you have to dig for the information. My recommendation is that if you're getting an inverter, get a pure sine wave one. Consider the cost of what you'll be plugging into it. The equipment that we ruined by opting for a cheap inverter cost far more than what a better inverter would have cost. And if you're going for a hardware inverter, I would definitely opt for the pure sine wave. Chances are very good that somewhere on the boat you'll plug in something that is sensitive to the waveform. Then we need to look at the power output. Due to less than perfect efficiency in changing power from one form to another, it's highly likely that items will be slightly less powerful than when plugged into shore power. For us, anything we put into the microwave took about 25% longer when it was running on the inverter. And after a summer at Anchor, Dave would inevitably forget to set the timer for a minute yet less when microwaving popcorn on shore power, and the first patch back at the marina would be burnt. And I'd like to hit 2 more things. They're really kind of beyond the scope of this, but I want to point them out. Before getting a large inverter and planning to run a bunch of appliances from it, make sure that you've got the battery bank and the charging ability. Just because your inverter can handle an air conditioner doesn't mean that the battery bank can. Second, inverters generate heat. Most have internal fans, which can get loud, but you don't want one without a fan, as it will shut down due to overheating. Once again, I am not an electrician. Prior to our first trip on a friend's boat, I had no clue what an inverter was or why I needed to switch it on before using the microwave. I learned a lot as we bought our boat and cruised. I've only scratched the surface here, but hopefully this information will give you a basic understanding of inverters and the questions to ask before buying, installing, or using one. Thanks for listening. If you like the show, please be sure to subscribe in your podcast app. Just search for the Boat Galley Podcast. And reviews are always appreciated. Until next time, then.
Slow down, slow down.